caliper. The apa namanya? The piston hub, oil seal, to check if it's damaged or not. So this the oil seal is in good condition. Then we check the piston, check the surface of the piston if it's damaged or not. Like this, it's in good condition. Then we check the dust cover. Like this, it is damaged little bit, so we have to change.
Chop the disc using chop.
Test the backpack through this.
Ada.
Okay.
Outboard 14.85, bed inboard 14.13, back bed inboard 14.13.
Itu betul.
Nombor 1 7.63.
7.63. Yang tu tadi 7.63 per point. 7.63. 7.52. Makin dekat yang poin yang kau buat. Ada tu.
Yang bersilang.
Di sebab kita nak tengok gauge ni dia ada lengkung tak? Kamu set kosong, set zero lah. Okay, set zero lepas tu pusing. Tengok dia punya macam tu je lah dia punya. Patut dia ada kalau dah lebih
dah.
Surface clearance is about 10 mm.
Okay.
Pin. Before we use it again, we must test this. Is it can use or not? So before we check you must find the flat face. So you must test like this. Okay, so easily can use.
Assalamualaikum, and my name is Muhammad Firdaus. Today I will tell about the disc brake part. The first is a caliper guide pin. The second is caliper guide pin boot. Third is brake pad for the inner part. Number 4 is the caliper bracket. The top was 5 Newton meter. Number 5 is caliper piston seal, and the number 6 is caliper piston. Number 7 is the dust boot. 8 is caliper housing. 9 caliper boot, and number 10 caliper mounting board, which is 74 Newton meter. 11 anti-sequel shim. Number 12 brake pad for the outer. Number 13 was wear indicator, and the last is 14, which is retainer clip. Okay, so from the lab we get the information for the condition of the disc brake part. First is wear indicator. The wear indicator in good condition. The second is the disc brake surface. The disc brake surface is rusted and need to be replaced. Number 3 is the out brake shoe. The condition is flat surface and can still be used, and the thickness was 15.26 mm. Okay, the number 4 is the inner brake shoe. The condition was surface not flat, and the thickness was 14.45 mm. And the number 5 is piston. Piston in good condition. And number 6 is cylinder bore. The cylinder bore in good condition. That's all from me. Thank you.
Hello, my name is Mu'aim. Here our disc brake inspection result. The condition of each task must be checked properly. First task is round out measurement. The thickness of this rotor is 0.01 mm. Therefore, this rotor is good condition and not exceed 0.05 mm. Next task to be inspected is the disc thickness, measurement by dividing to 6 points. Based on out disc thickness measurement, the data collected at 6 points accordingly is first 7.67, second 7.02, third 7.52, and then 7.31, and then 7.32 and 7.69. The third task is inspection is rub test. The measurement collect is 10 mm, which are still thick and can be used. Last but not least, the task to be inspected is guide pin, or known as lock pin strictness. From our inspection, the lock pin is still in good condition and can be used. Next, we proceed to discussion. The discussion is list 2 causes of rotor thickness variation. What is the correct repair procedure of thickness variation? 2 causes of rotor thickness variation might be uneven pad wear due to sticking caliper slide, a size caliper piston, or uneven braking force distribution, which lead to inconsistent pad contact and uneven rotor wear. So next is vapor or overheated rotors. This is due to excessive heat, which cause rotor to warp and develop hard spot. The variation of hardness can cause uneven wear when the brake pad contact the rotor surface repeatedly. So, what is the correct procedure of the thickness variation? First, we should measure rotor thickness by using a micrometer at multiple points around the rotor to confirm the variation and assess if it within allowable limit. Thank you.
let's discuss about run out measurement data. What is run out measure? Run out specifically measure the lateral movement or side-to-side variation in the rotor surface. This movement causes the rotor to oscillate slightly as it rotates, which can lead to uneven contact with the brake pads. Causes of run out. Run out can be caused by issue like improper installation, dirt or rust between the rotor and the hub or warped rotors. It may also result from uneven tightening of wheel lug nuts. Acceptable limits for run out. Manufacturers typically specify maximum allowable run out limits, often in the range of 0.05 mm to 0.1 mm. How run out is measured? Diode indicator. A diode indicator gauge is often used to measure rotor run out. The gauge is positioned against the rotor surface while the rotor is rotated and records any deviation in the rotor's lateral movement. Measuring points. Measurements are typically taken at several points around the rotor, usually in at least 3 to 5 positions to get an accurate reading of any variation.
Okay, the next question is what is your finding for the guide pin straightness check? And what can happen to your disc brake system if the guide pin is not straight? Finding for the guide pin or lock pin straightness check. When checking the straightness of a guide pin, the pin should be completely straight with no signs of bending. A straight pin ensures that the brake caliper can slide smoothly and evenly, which is essential for proper braking function. If the guide pin or lock pin is not straight, uh, likely it will likely cause bonding or uneven movement with the caliper, leading to several issues. The impact if the guide pin is not straight. The first one is uneven brake pad wear. A bend or misaligned guide pin prevents the caliper from moving freely, causing the brake pad, causing one brake pad to make more contact with the rotor than the other. This result is uneven brake pad wear, reducing the lifespan of the pads and potentially causing need for more frequent replacement. The second one is brake drag. When the caliper cannot slide properly, one of the pad may remain in constant, will remain in contact with the rotor even when the brake is not applied. This brake leads to overheating of the rotor and pads, reduce fuel efficiency and potential damage to brake component. The third one is reduced braking efficiency. Sticking or binding caliper can result in reduced or inconsistent brake force, making the braking system less effective and possibly dangerous. This can increase stopping and reduce the vehicle's overall braking performance. The fourth one is vibration and noise. A misaligned guide pin can cause the caliper to uneven pressure, leading to vibration, pulsation in the brake pedal when braking. It can also cause unusual voice noises like squealing and grinding due to uneven pad contact or brake depth. The last one is increased rotor wear. Uneven caliper movement can lead to hotspot, hotspots on the rotor, resulting in rotor warping and premature wear. This can cause the rotor thickness variation, further degrading braking performance and requiring rotor resurfacing or replacement.
So, in summary, the disc brake system components are in good condition, with no issue observed in run out, thickness, or individual part. The brake disc can continue to be used safely without additional repairs or adjustment. This experiment suggests that the braking performance should be effective and no immediate maintenance action are necessary. Thank you.